Welcome to AudioCert, where the official study guides are brought to life. I'm so excited to guide you through what promises to be a really crucial deep dive today. We're going straight into the heart of digital investigations. Our focus: EC Council's Computer Hacking Forensic Investigator, or CHFI, certification. Specifically, we'll be breaking down Chapter 13, Forensic Software and Hardware. Now, for those of you on your path to becoming a CHFI, you know this certification is all about equipping professionals with the indispensable skills needed to identify, collect, preserve, and, well, meticulously analyze digital evidence. Think of it as becoming a digital detective, sifting through the digital fingerprints and traces left behind in the vast expanse of cyberspace. And today's chapter, Forensic Software and Hardware, is absolutely paramount to that mission. In the world of digital forensics, your tools are your trade right, but merely having a toolbox isn't enough. You need to understand which tools to use, when to use them, and how they actually work. This deep dive is your shortcut to mastering that essential toolkit.
And that's precisely why this discussion is so critical. Without the right specialized software and hardware, even the most skilled and intuitive investigator would struggle immensely to uncover the hidden truth within digital evidence. Imagine trying to solve a complex puzzle with half the pieces missing, or, I don't know, using a butter knife to perform delicate surgery. It just wouldn't work. The landscape of forensic tools is vast and, frankly, constantly evolving, making a structured and fundamental understanding absolutely essential for anyone entering or working in this field. So today, our mission is to unpack the features, the distinct advantages, and the real-world applications of a wide array of these tools. We'll explore both the software-based solutions that run on computers and the physical hardware devices that provide direct, unassailable control. By the end of this, you, our listener, will be well-equipped to understand their vital role in real-world investigations.
Okay, let's unpack this then. It sounds like we can't just rely on the everyday software that comes pre-installed on our computers, or even common utility programs we might download. Why can't a forensic investigator just use standard everyday software to find evidence? What makes these forensic tools so unique and absolutely necessary?
That's an excellent question, and it really gets to the core of digital forensics. The fundamental principles driving forensic tool design are all about protecting the integrity of the evidence and, crucially, ensuring its admissibility in a court of law. Standard tools, well, they simply don't adhere to these principles. First and foremost is data integrity. This is the primary concern always for any forensic investigator. When you use standard tools, say just opening a file in Windows Explorer, you can inadvertently alter crucial metadata, things like the last access date and time.
Oh, right, like leaving your fingerprints all over the place when you shouldn't.
Exactly. Think of metadata as the digital fingerprints or timestamps on a piece of evidence. In a legal context, even minor alterations can compromise the evidence, making it inadmissible. Forensic tools, on the other hand, are meticulously designed to never write to the evidence source. They operate in a read-only manner, ensuring that the original digital artifact remains pristine and unaltered, like sealing a crime scene before anything is touched. This is foundational.
Okay, so integrity first. What else?
Secondly, there's the depth of analysis. Standard operating system tools only show you what the operating system wants you to see, the allocated files, the visible directories, the surface level. But digital evidence often hides in plain sight, or maybe in the digital shadows. Forensic tools delve deep into areas like unallocated space.
Unallocated space. That's like where deleted files might still hang around.
Precisely. It's space on a drive marked as free by the OS, but it may still contain remnants, sometimes whole files, that were previously deleted. Think of it as the digital landfill where old data goes to die but isn't truly gone yet. They also explore slack space. That's the unused portion of the last data block or cluster assigned to a file. It's like finding a tiny note tucked into the unused margins of a document.
Wow, okay.
Forensic tools can also uncover hidden partitions that the operating system doesn't normally display, and they can directly analyze raw data, bypassing file systems altogether. This is where crucial evidence often resides long after a user thinks they've deleted something permanently.
So they dig much, much deeper than regular software.
Much deeper. And then we need to consider efficiency and scale. Imagine dealing with terabytes of data from multiple hard drives. We're talking potentially thousands or millions of files. Consumer-grade or standard software just doesn't offer the specialized indexing, searching, and processing capabilities needed to handle that kind of volume efficiently. It would take forever.
Yeah, trying to search terabytes with Windows search? No
No.
thanks.
Exactly. Forensic tools are built for speed and scale, allowing investigators to sift through massive amounts of data in a reasonable time frame, like having a superpowered librarian for digital information. And finally, there's legitimacy and admissibility. This is huge. For evidence to stand up in a legal setting, the tools used to collect and analyze it must be validated. Their output must be verifiable. You need to be able to demonstrate in court that your tools function as expected and produce reliable, untainted results, that they haven't introduced errors or changed anything.
Okay, here's where it gets really interesting for me. You mentioned validation. Who exactly is checking these tools? How do we know they meet these really stringent requirements? You say like, a thumbs up from a tech blog or something far more official.
Oh, it's far more official, and it's a critical component of maintaining trust in digital evidence. A key player in this validation process is the National Institute of Standards and Technologies, or NIST's, Computer Forensic Tools Testing Project. It's usually called CFTT.
NIST CFTT.
Got it. NIST CFTT is a truly critical resource. They provide independent evaluation and testing of forensic tools. They publish detailed technical reports that outline their findings, specifically for things like disk imaging tools and software write blockers. You can actually find a lot of this valuable information on our website, www.cftt.nist.gov. They have specific sections for disk imaging, presentations, and software write blockers. It's a great resource.
It's not just the vendor saying, our tool is great.
Exactly. It's important to understand that while vendors naturally highlight the strengths of their products in, product sheets and marketing materials, NIST's CFTT provides an unbiased, independent assessment. This makes their reports incredibly valuable for comparative data. It allows practitioners like you to make informed decisions about which tools best suit your needs and, importantly, which ones can withstand legal scrutiny. They are essentially the independent auditors for forensic technology.
That makes a huge difference, knowing there's that independent check. Okay, so let's dive into the digital toolbox first. There are so many software solutions, seemingly each with its own specialty. Where should we even begin to make sense of this vast array? It feels a bit overwhelming.
It can feel that way. A good approach is to think about the types of investigative tasks we'd encounter. So let's begin with software designed for monitoring and tracking usage, sort of getting that high-level view of what a computer has been doing.
All right, monitoring and tracking. What's an example?
A great example here is Visual Time Analyzer. Its core function is to automatically track all computer usage and then generate detailed, often illustrated reports on user activity. Now, this isn't about deep content snooping, like reading emails or logging keystrokes. It's more about understanding patterns of activity.
Okay, so patterns. How would that be used?
Well, imagine its practical applications. For user supervision, it can give you detailed accounts of working hours and breaks.
Useful in corporate settings, maybe, for productivity checks or investigating misuse of company time.
Precisely. It can help investigate those kinds of issues without being overly intrusive. It also helps with general computer supervision for networks, or even software metering.
Software metering, like seeing who's using what software.
Exactly. Determining how often software is used and by whom that's valuable for license compliance, or identifying unauthorized software use. It can also assist with internet use control, helping understand online time and web usage patterns. But what's really crucial here are its built-in privacy safeguards. Visual Time Analyzer specifically does not monitor passwords, personal documents, individual keystrokes, or run screen captures.
So it's definitely not spyware.
Right. It's an activity logger, not a content spy. Think of it like a detailed logbook for a building. It shows which rooms were entered, when, and for how long. But it doesn't record any conversations that happened inside those rooms. It gives you the what and when of activity, not the who said what or the specific content.
That makes a lot of sense, especially drawing that line. Understanding behavior without digging too deep into private content unless necessary. Okay, what's next?
Next, let's move to the real heavy hitters.
Now, for the heavy lifting, you mean the comprehensive platforms, the ones digital investigators rely on for those deep dives into drives. These sound like the command centers for an investigation, handling most of the core tasks.
Precisely. These are the powerful, often all-in-one solutions that form the backbone of many, many investigations. One of the most prominent and well-respected is Xway's Forensics. It's actually based on an older tool called WinHex, but it's evolved significantly. It's designed as an advanced work environment specifically for the digital forensic analyst, offering incredible versatility.
Okay, Xway's Forensics. What makes it so versatile? What can it do?
Let's highlight some of its most impactful features. First, Its ability for forensic cloning and imaging of sound disks is paramount. This means creating those exact bit-for-bit copies of evidence drives without altering the original in any way. Crucially, it boasts native support for a wide array of file systems. We're talking FAT, NTFS, XT2, XT3, XT4, which you find in Linux, CDFS, UDF for optical media, HFS, HFS Plus for Apple systems, RiserFS, UFS, the list goes on.
Wow, that breadth is critical, isn't it? You never know what kind of system you'll encounter.
Absolutely. You might get a Mac drive, a Linux server disk, an old Windows machine. Xways can likely handle the file system directly. What's also truly powerful here is its built-in interpretation of RAID 0 and RAID 5 systems and dynamic disks.
RAID. That's done an array of independent disks, right? Those complex multi-disk setups.
That's the one. Analyzing RAID setups can be very complex, but Xways can often interpret these configurations directly, saving investigators immense amounts of time and effort. It also offers powerful data recovery techniques and file carving. This is essential for retrieving deleted or fragmented files that might contain crucial evidence.
File carving. That's like finding files even if the file system doesn't know they're there anymore, based on their structure.
Exactly. It looks for known file headers and footers to piece things back together. A key feature for discovering hidden data is its detection of NTFS alternate data streams, or ADS.
ADS, I've heard of those. That's a classic hiding spot for malicious data or malware, right?
Right.
So specific detection is vital.
It is. ADS are essentially hidden data streams attached to regular files, and they're notoriously used to conceal information. Xways specifically looks for these. And of course, for proving the integrity of your evidence, it performs hash calculation using CRC32, MD5, SHA1, and SHA256.
Hashing creating those unique digital fingerprints to prove nothing's changed.
Precisely. These ensure that copies are identical to the original and haven't been tampered with. It's fundamental for the chain of custody. So if we connect this to the bigger picture, Xways is like a forensic multi-tool. It combines the functions of many individual instruments into one powerful, versatile device.
Wow, that's incredibly comprehensive. It really does sound like a one-stop shop for a lot of an investigator's needs. But I wonder, if it's so powerful, are there any trade-offs? Or maybe scenarios where a specialized single-purpose tool might still be better?
That's a very insightful question. While Xways is a powerhouse, the trade-off can sometimes be a steeper learning curve, just given its vast functionality. There's a lot there. And for some very specific niche tasks, yes, a highly specialized tool might offer a unique algorithm or perhaps a more streamlined interface just for that one specific function. Maybe it's marginally faster or has a proprietary technique for, say, a very specific type of email parsing or complex encryption cracking.
Okay, so edge cases mostly.
Often, yes. For the majority of a digital investigation, a comprehensive platform like Xways is incredibly efficient. Speaking of comprehensive platforms, another leading name, a real industry standard you'll hear about constantly, is Incase from Guidance software.
Incase, right, heard that name a lot.
Incase is a very robust forensic data and analysis program. It's also designed for case management and digital investigations. Its core capabilities include simplifying computer system searches, thoroughly documenting findings, creating those forensically sound evidentiary copies, and really allowing users to understand and define the information they've collected. Incase is particularly renowned for its comprehensive case management features. These are vital for organizing complex, multifaceted investigations, especially when you expect to present findings in court.
Case management seems crucial when you're dealing with potentially huge amounts of data and different types of evidence.
It really is. Keeping everything organized, logged, and reportable is key.
All right. So often the challenge isn't just seeing what's currently there, but finding what's been hidden or deleted. That's where specialized data recovery and deep search tools come in, right? The stuff that makes you feel like a digital archaeologist digging for buried treasure.
Exactly. These tools are specifically designed to dig into those deeper layers where information might be deliberately concealed or simply lost due to normal system actions or attempts to cover tracks. Let's look at a few examples. Evidor, for instance, is excellent for targeted keyword searches. It looks for keyword occurrences within text files across digital media, like hard disks. And crucially, it retrieves the context around those keywords, not just the word itself.
Context is key, I imagine.
Absolutely. Its scope extends to allocated space, those Windows swappaging and Hibernate files, and importantly, the critical unallocated and slack space. It can even find deleted data if it still physically exists on the hard disk platters. It's very valuable for quick, focused hunts when you know what terms you're looking for.
Okay, quick and targeted. What about mobile devices? They're everywhere now.
Mobile devices are essentially mini computers these days, absolutely packed with crucial evidence. That's where device seizure from Paraben Corporation comes in. This is specialized software designed for forensically analyzing and recovering mobile phone and PDA data. Think deleted text messages, photos, call logs.
Stuff people delete thinking it's gone forever.
Exactly. Its device support is extensive, covering many types of phones like Palm, Windows Mobile, BlackBerry, and specific models from Nokia, Samsung, LG, and others. It even supports GSM SIM card acquisition and deleted data recovery using something called SIMCON technology.
Mobile devices are mini computers these days, and crucial evidence resides there. This sounds indispensable.
It truly is. Mobile forensics is a huge field in itself, and tools like device seizure are essential because mobile devices are treasure troves of personal and evidentiary data that require very specific methods to extract forensically without altering them.
Makes sense. What else in the specialized recovery area?
Next, we have forensic sorter, also from Paraben. Its function is to organize and speed up the examination of hard drive contents. It does this by sorting files into intuitive categories like video, audio, spreadsheets, etc.
So it helps you quickly find, say, all the images or all the documents.
Precisely. It makes it much easier to find specific types of evidence quickly. What's really crucial here, though, is how it sorts. It sorts files by their internal header signature rather than relying just on the file extension.
Why is sorting by header so important?
Because file extensions can be easily faked or changed to disguise a file's true nature. Someone could rename a malicious executable file as a harmless text file, for example. Forensic sorter looks at the actual internal structure, the header, to determine the true file type. That's vital for accuracy. It can also sort files found in unpartitioned space and identify encrypted files.
Ah, that's clever. Avoiding being tricked by a simple rename. Got it.
And one more in this category, Directory Snoop. This is a cluster-level search tool for FAT and NTFS disk drives. It allows investigators to analyze and view files, recover deleted files, even those emptied from the recycle bin, and it can also permanently erase sensitive files using secure wiping functionality.
So it does recovery and secure deletion.
Yes, and it particularly excels at securely wiping slack and free drive space and purging sensitive file names that might be left behind even after normal erasing. This tool helps confirm that sensitive information is truly gone from a drive or helps recover things others might miss.
Okay, which brings us neatly to wiping. Just as important as recovering data, sometimes more so, is the ability to securely erase it. This is about ensuring data is truly gone, not just deleted, which we know isn't really deleted in the digital sense. This seems crucial for security, privacy, and compliance.
Absolutely. Drive wiping, or data sanitization, is a crucial component of digital forensics practice, especially when reusing media, disposing of old hardware, or handling highly sensitive data. The principle is simple. Any drive not thoroughly wiped according to proven standards has to be considered suspect, potentially containing residual data. We have tools specifically designed for this.
Like what? What makes them different from just formatting a drive?
Oh, vastly different. Formatting often just removes the pointers to the data, not the data itself. Secure wiping overwrites the data, often multiple times with specific patterns. PD wipe, for instance, is capable of wiping large hard drives, even those exceeding 8.4 gigabytes, in under 11 minutes, which is remarkably fast for a secure wipe. It performs a declassification wipe in accordance with the NAVI-SO P523910 security standard. This wiping algorithm actually exceeds the Department of Defense, DoD, 5220.222M specification for both clearing and purging sensitive information.
Exceeds the DoD standard. That sounds serious.
It is. It uses a highly rigorous method to ensure data is irretrievably erased, vital for high-security environments or situations demanding the highest level of data destruction. PDWipe also offers flexibility. You can specify a character code other than all zeros when wiping or use a random pattern. It can process all drives in a system with a single command and generates activity reports. Plus, it verifies that randomly chosen sectors, as well as the first and last sectors, have been successfully wiped.
So if you truly want to make sure your old laptop's data is irretrievable before you donate or sell it, what's a good accessible option for, say, a home user or a small business?
For that very scenario, Derek's Boot and Nuke, usually just called DBAN, is an excellent and widely used choice. It's a free, self-contained boot floppy or CD image that you can create. It's available from dban.sourceforge.net.
Free and bootable, nice.
Yes, it's designed to securely wipe the hard disks of most computers automatically and completely. This makes it an appropriate utility for bulk or emergency data destruction, ensuring due diligence in computer recycling, preventing identity theft when selling a computer, or maybe thoroughly cleaning a Windows installation of stubborn viruses and spyware. It's specifically engineered to prevent or thoroughly hinder all known techniques of hard disk forensic analysis. Basically, it aims to render the data forensically sterile, leaving no trace behind.
So DBAN is your friend if you want that data gone for good.
Absolutely. If the goal is irretrievable deletion, DBAN is a very effective tool.
Okay, now shifting focus a bit. Failing to maintain the integrity of a file or a drive image, as you said, can end a forensic examination right there. So what tools help us prove that evidence hasn't been altered, and also help understand timelines by meticulously analyzing file dates and times?
Right, this is about documentation and temporal analysis. Filemon, for example, was a critical utility for older Windows systems like Windows 95, 98. It monitored and displayed file system activity in real time. Its advanced capabilities allowed investigators to explore the inner workings of Windows, observe how applications used files in dynamic link libraries, or DLLs, and track down system or application file configuration problems.
DLLs, of those shared library files.
Exactly. Filemon's timestamping feature precisely showed when every open, read, write, or delete operation occurred, along with its outcome. It gave you a live view of file system interactions. Now, it's worth noting that Filemon has been largely replaced by Process Monitor on newer Windows versions, but its principles monitoring file system calls remain essential for certain types of analysis.
So understanding when files were accessed or changed. What about finding timestamps hidden within files?
That's where another type of tool comes in, File Date Time Extractor, or FDTE, from Digital Detectives. This tool searches through binary files like executables or documents to uncover hidden, embedded 64-bit date and time data. These are often found in Windows files like Word documents, for example.
Hidden timestamps inside files. That sounds incredibly useful for building timelines. But you mentioned a caution earlier.
Yes, and it's a significant one. FDTE notes that false positives are common. This is because random data patterns within files might look like timestamps to the tool but aren't actual time records.
False positives. Ouch. That sounds like a minefield for investigators trying to piece together an accurate timeline. How do you possibly navigate that uncertainty?
It absolutely is a challenge, which is why cross-validation with other data points and a deep understanding of the file structures you're examining are so crucial. You never rely on a single piece of information or a single tool's output, especially when it warns about false positives. Complementing FDTE, we have the Decode Forensic Data Time Decoder. This utility was designed specifically to decode a vast array of different date and time values embedded within binary and other file types. It supports numerous formats: Windows 64-bit, both little and big endian, cookie format, file time, Unix 32-bit, little big endian, numeric, MC absolute timestamps, MS-DOS 32-bit, and HFS plus 32-bit, little big endian.
That's a lot of formats.
It is. It even allows you to specify a GMT or Greenwich Mean Time offset to adjust for time zones. It can convert decimal or hexadecimal values it finds into human-readable date and time in various formats. And importantly, it's aware of where these formats are typically found, places like Internet History Index.dat files, RecycleBin INFO files, Windows Link Files.lnk, and various Microsoft Office documents. So think of this tool like a universal translator for time, making sense of how different systems and applications record moments in their own unique language. It helps navigate that false positive minefield by understanding the context and format.
A universal translator for time. I like that analogy. Okay, moving on to another fundamental process. Imaging. You said creating a bit image copy is like making an exact cast of a footprint. What tools help with that?
Yes. Creating that perfect, unaltered replica is step one in many cases. Consider Snapback Data Rest. This tool excels at obtaining mirror images of different operating systems and provides successful backups of hard disk data. It's particularly designed for mission-critical data where reliability is paramount. The captured image contains a truly comprehensive set of data. all system and networking software with associated drivers, applications, configurations, all files including deleted ones, slack space, data files, and even the CMOS settings for the system hardware.
So literally everything.
Everything. It offers various data gathering modes, like copying hard drives to tape, to removable media, or hard drives to hard drives. Its core strength is obtaining that forensically sound bit-level backup of data.
And alternatives, maybe something from the Linux world.
Absolutely. There's Partimage, which is a well-known Linux utility. This tool saves partitions that have a supported file system to an image file. It supports most common Linux and Windows file systems. To save disk space, the image file can be compressed using standard tools like gzip or bzip2. And for convenience, especially with large partitions, it can be split into multiple files, perfect for burning onto CDs or DVDs.
Splitting is handy.
Very. Partitions can also be saved across a network using Partimage network support or protocols like Samba or NFS. And a really useful feature, especially for field forensics, is that Partimage can often be run from a bootable CD without needing to be installed on the system itself, offering great flexibility.
Okay, imaging covered. Now, this chapter really emphasizes the sheer breadth of tools available. It's not just about recovering files or imaging drives. It seems like there are tools for everything, from cracking passwords to parsing emails and understanding system startup processes. Let's try and touch on some of these other vital categories.
Absolutely. The investigative process requires a diverse arsenal, covering many different aspects of a system and user activity. Let's start with password recovery tools. The basic concept behind most of these is that the password cracker takes lists of words, dictionaries, hashes them using the same algorithm as the system uses for passwords, and then compares those hashes with the password hashes found on the target system. If a match is found, the dictionary word is likely the password.
So it's like trying millions of keys until one fits.
In essence, yes, especially with brute force variations. A leading tool historically has been at Stake's LoftCrack 5. This was an award-winning password auditing and recovery application widely used to identify and resolve security vulnerabilities by finding weak passwords. It could recover Windows and Unix account passwords and offered rapid processing using pre-computed password tables, sometimes called rainbow tables.
Pre-computed tables. That speeds things up considerably.
Immensely, compared to trying every single combination from scratch. Another advanced suite is Parabin's Decryption Collection Enterprise. One of its most powerful features is its ability to distribute the processing load across a network of up to 16 computers.
Wow, distributed cracking.
Yes, this significantly accelerates brute force or dictionary attacks, which is crucial when facing complex, lengthy passwords that would take a single machine potentially years to crack.
Okay, password recovery is one thing. What about digging into internet activity? That seems critical in so many cases now.
It is. For internet activity and web browser forensics, tools like net analysis are invaluable. This tool allows for the detailed analysis of web browser history data. You can view web history, examine the browser cache contents, and even extract relevant data from unallocated space on the drive.
Extracting browser artifacts from unallocated space, that's powerful.
Very. It's commonly used to reconstruct a user's online activities, like websites visited, searches performed, and files downloaded, even if they tried to delete their tracks using the browser's clear history functions.
So clearing history doesn't mean it's really gone forensically.
Often, no. Traces remain. Then we have various multi-purpose tools. Take WinHex, for example. As I mentioned, it began life as a hexadecimal editor, a tool for viewing and editing the raw bytes of files. But it evolved into a powerful forensic tool in its own right. It can inspect and edit all types of files at a very low level, recover deleted files and lost data from hard drives or digital camera cards, and it even includes a RAM editor for accessing the virtual memory of running processes. It's excellent for that deep, low-level data inspection and manipulation.
Like a digital scalpel.
A good way to put it. Now, for understanding what happens when a system starts up, Autoruns from Microsoft is incredibly useful. It offers probably the most comprehensive display of Autostart locations of any startup monitor available. It shows you all the programs configured to run during system boot or login. This goes way beyond the standard msconfig utility built into Windows. It checks a startup folder, run keys in the registry, run-ins keys, explore shell extensions, browser helper objects, toolbars, scheduled tasks, services, everything.
So it finds things hidden in obscure places.
Exactly. Forensically, its hide signed Microsoft entries option is very helpful. It allows you to quickly filter out legitimate Microsoft components and focus on third-party Autostart images, which could potentially indicate malware or unauthorized software installations.
That filtering feature sounds like a real time saver.
It is. And now, in the early stages of an investigation, especially with large drives, it's often impractical to examine every single file individually. That's where a tool like Hashdig comes in handy. Hashdig is essentially a collection of utilities designed to automate MD5 and SHA-1 hash resolution. Remember, hashing creates unique fingerprints for files.
Right, the digital fingerprints.
Hashdig helps quickly reduce the number of files requiring manual examination by grouping them into known good or known bad or simply unknown categories. It does this by comparing the hashes of files on the evidence drive against large reference databases of known file hashes, like standard OS files, common applications, or known malware.
So it sorts the files automatically based on whether they're common, known bad, or need closer inspection.
Precisely. This significantly reduces manual effort and helps investigators triage large data sets much more efficiently, focusing their attention where it's most needed.
Triage for digital files. Makes sense. And finally, what about analyzing compiled code? Like figuring out what a program actually does if you don't have the source code.
That falls into the realm of reverse engineering. The Reverse Engineering Compiler, or REC, along with its graphical user interface companion Rex Studio, is a portable decompiler. It reads executable files, like .exe files, and attempts to produce a C-style representation of the underlying machine code and data structures. It essentially tries to reconstruct a human-readable version of the program's logic.
This sounds like something out of a spy movie, pulling apart compiled programs to see how they tick.
It's incredibly powerful, and yes, it feels a bit like that sometimes. This tool is crucial for understanding malware, how it operates, what its capabilities are. It's also used for analyzing proprietary software where the source code isn't available, or for unearthing hidden functionalities or vulnerabilities that might be embedded deep within compiled code. It essentially lets you peek under the hood of a program.
Fascinating. Okay, that was a deep dive into some key software tools and categories. But looking at the full range of tools mentioned in the study guide, Table 13.1 specifically, it's truly enormous. How do we even begin to conceptualize this immense arsenal without getting completely overwhelmed? It's like trying to remember every single type of screwdriver and wrench in a giant workshop.
That's a great analogy, and you've hit on the key insight here. It's not about memorizing every single tool name. That would be nearly impossible and not very useful. It's about understanding the categories of capabilities they represent and the types of problems they solve. The sheer number of tools really just reflects the incredible diversity of digital evidence, platforms, file types, and operating systems an investigator might encounter. There's a tool for almost every niche.
So think categories, not individual names.
Exactly. Instead of trying to list them all, let's think about the different hats an investigator wears during a case and the corresponding tool categories. You've got your deep dive data recovery hat. Beyond what the core platforms offer, you'll find specialized tools laser-focused on recovering specific file types like photos or databases, or data from severely damaged or formatted media. They excel at bringing back what seems truly lost or fragmented. Then there's the metadata and file analysis hat. These tools let you quickly understand a file's history, its hidden properties like EXIF data in images, or even its true file type regardless of the extension. They help uncover details about how, when, and where a file was created, modified, or accessed. The Internet and Communication Forensics hat is vital. This category is all about reconstructing online activity, browsing history, cache data, cookies, email messages, even deleted ones, chat logs, social media artifacts. These tools help piece together digital conversations and web-based actions. Sometimes you wear the system behavior monitoring hat. Beyond just startup programs, these tools provide real-time or post-mortem insights into what processes were running, what network connections were active, what files processes were accessing, and how the operating system itself was behaving. They're like an X-ray into a live or recently active system. And of course, the specialized encryption password solutions hat. These are the keys to locked data, from simple password decoders for specific applications like old AIM clients or Access databases, to powerful suites that can tackle strong encryption using distributed computing for brute force or dictionary attacks. They address the critical challenge of inaccessible information.
Seeing them as categories or hats makes it much more manageable.
As you can see, for almost every digital task or artifact an investigator might encounter, there's likely a specialized software approach designed to handle it forensically. The real key is knowing what problem you're trying to solve and selecting the appropriate, validated tool for that specific job.
That reframes it perfectly. It's about understanding the function, not just the tool name. Which brings up two common questions I imagine listeners might have, questions I certainly have. First, looking at that huge list, do we really need all the tools mentioned? And second, Many of these tools seem to run on operating systems I might not be super familiar with, like various Linux distributions or even older Windows versions. Do I need to become an expert in all these operating systems?
Great questions. And the answer to the first one is no, you absolutely don't need them all. It's important to become familiar with a wide range of tools and understand their functions, their strengths, their weaknesses. But it is not necessary or even practical to have or master every single tool listed. Your understanding of their capabilities and applications is what's truly key. Over time, through practice and experience, you'll build your own preferred toolkit, the set of tools you trust and know how to use effectively.
Okay, build your own toolkit based on understanding the functions. What about the operating systems? Do I need to be a Linux guru and a Windows expert and know macOS inside out?
While broad familiarity with diverse systems is certainly beneficial for any digital forensic investigator, it helps you understand context. You definitely don't need to be a deep expert in every single operating system out there. The good news is that most essential forensic functions are covered by tools available across different operating systems. Whether you're most comfortable working in a Linux environment, a Windows environment, or maybe even Mac OS, it's highly likely you'll find a capable tool that performs the specific function you need running natively on your preferred operating system. It comes back to knowing the forensic principles, knowing what task needs to be done, and then selecting the right tool for your environment and the evidence you're facing.
That's reassuring. Focus on the principles and find the tools that work for you. Okay, let's switch gears now. We've talked a lot about software, the digital realm. Let's move to the tangible world. What distinct advantages do physical hardware tools offer in a forensic investigation compared to just using software?
That's a fundamental distinction. And hardware tools offer some truly significant benefits, advantages that software alone often can't quite match, especially at the acquisition stage.
Okay, what kind of advantages?
Well, firstly, a major advantage is embedded development. The specialized functions are built directly into the hardware device itself. This often saves space, saves setup time, and generally simplifies the acquisition process because the device is purpose-built for its specific forensic task, like write blocking or imaging. Secondly, they typically offer greater portability. Many hardware forensic tools are compact, self-contained, and easy to operate in the field, making them ideal for on-scene acquisitions where you might not have a full lab setup.
So easier to carry around and use on-site.
Often, yes. Thirdly, there's frequently increased speed. Hardware devices, especially dedicated imagers, can often acquire digital data much, much faster than software-only solutions running on a general-purpose computer, particularly for creating those bit-for-bit images of large drives. And finally, perhaps most importantly for integrity, they provide control at the lowest level. Hardware tools, like write blockers, interact directly with the storage device's interface, like IDE or SATA, bypassing the operating system layers entirely.
Bypassing the OS, why is that so important?
Because it ensures absolute integrity of the data acquisition. There's virtually no chance of the computer's operating system interfering, caching data, or inadvertently writing anything to the evidence drive. The hardware physically prevents it. Now, a practical point here. It's crucial for the forensic analyst planning a job to ensure they have all the possible connectors and adapters available before starting. Given the sheer variety of media types out there, different ID standards, SATA, SCSI, various flash formats, you need the right physical interface.
Good tip. Be prepared with the right adapters.
And just like with software, I want to remind listeners that NIST CFTT also tests and rates hardware tools, particularly hardware write blockers. You can find their reports at www.cft.nist.gov/hardware-write-block.htm. Always good to check for independent validation.
Okay, let's talk about those write blockers first. These sound absolutely critical, right? The whole point is to ensure nothing, absolutely nothing, changes on the original evidence drive. This is like the ultimate do-not-touch mechanism for digital evidence.
They are indeed absolutely critical. Hardware write blockers offer a simple and importantly less error-prone method to acquire an image of a suspect drive compared to relying solely on software configurations for write blocking. Software methods can work, but they can be complex to set up correctly and are potentially prone to user error. Hardware makes the process simpler and vastly more reliable. It takes the guesswork out.
Makes sense. What are some examples?
Let's look at No Write by MyKey Technologies, Inc. Its core function is simple: prevent any data from being written to the hard disk connected through it. It supports high-capacity drives and is compatible with a wide range of connection methods: USB, FireWire, standard IDE interface cables. What's truly impressive about No Write, and devices like it, is its transparency to the operating system. MS-DOS, Windows, Linux, Sun, macOS. The host operating system cannot even detect that the write blocker is there. It provides an invisible, purely hardware-level write block. The OS sends a write command, the hardware simply doesn't pass it to the drive.
Invisible protection. Cool.
Then there's lockdown by paraben. This is often described as an advanced FireWire to ID or USB to IDE write blocker. It combines speed, using interfaces like FireWire or USB 2.0, and portability, making it ideal for quick and safe acquisition of IDE-based media, especially when using Windows-based forensic workstations. It's typically part of a complete field kit, coming with various cables like 40-wire, 80-wire IDE, notebook drive adapters, FireWire and USB cables, power supplies, all in a carrying case. It allows for hot swapping suspect hard drives without restarting the forensic computer, which can be a time saver.
So a portable kit for IDE drives. What about all the flash memory we use now? SD cards, USB sticks.
Excellent point. For that, you have devices like the Write Protect card reader from Intelligent Computer Solutions, or ICS. Its specific function is to allow you to transfer data from digital cameras, camcorders, PDAs, MP3 players, digital voice recorders, anything, using common flash memory cards to a computer, while simultaneously blocking any writes back to that flash memory card.
Crucial for things like SD cards from a camera, which can be easily altered.
Exactly. Preserving the integrity of volatile flash media is vital. This reader is typically small, palm-sized, connects via USB, and requires no external power. It's bus-powered. It supports a wide range of media types like compact flash, smart media, memory stick variants, SD cards, microdrives, and more. ICS also offers specific interface blockers like the DriveLock IDE and the Serial ATA DriveLock Kit. As their names suggest, these devices connect in-line with IDE, PATA, or SATA interfaces and physically prevent any write commands from reaching the connected hard drive. They ensure that write commands are blocked during any preview or duplication process. Think of all these hardware write blockers as that digital do not touch sign, but one that's enforced by physical hardware locks, ensuring the original evidence remains pristine and unaltered.
Physically enforced, do not touch.
Got it.
Right.
Okay, so once the evidence is securely protected with a write blocker, the next crucial step is often to make perfect, rapid copies for analysis. This sounds like where dedicated hardware duplicators and wipers really shine. Exactly. These dedicated hardware devices combine speed, often built-in integrity features like hashing, and sometimes sanitization or wiping capabilities, all in one robust package designed for forensic workflows.
Let's start with wiping again, but on the hardware side.
Okay. Consider the Wipe Master from ICS. This is a commercial-grade drive wiper built for high-volume work. It's incredibly efficient, capable of wiping up to 9 hard drives simultaneously at speeds exceeding 2.6 gigabytes per minute for a single pass wipe.
9 drives at once. Wow.
Yes, and it adheres to the rigorous U.S. Department of Defense standard DoD 5220.22 TM for data sanitization. After each wipe cycle, it provides a forensic audit printout confirming the secure erasure process was completed successfully. Crucially, there's virtually no degradation in speed when adding more drives up to its maximum capacity. It just powers through them. It even supports unlocking and wiping those hidden host protected area, HPA, and device configuration overlay, DCO areas on drive.
HPA and DCO, those hidden spots where data or malware could be hiding.
Precisely. Standard wiping might miss those, but forensic-grade wipers like this are designed to access and sanitize them completely.
Okay, that's wiping. What about high-speed copying or imaging with hardware?
For high-speed data acquisition, ICS offers devices like the ImageMaster Solo 3 IT. This is designed as a lightweight, portable, handheld device specifically for forensic data acquisition in the field or lab. It can acquire data to 1 or 2 evidence drives simultaneously at very high speeds, often exceeding 3 gigabytes per minute. It's capable of capturing data from various source drives: IDE, laptop drives, Serial ATA, SATA, SCSI drives, and even flash cards with the right adapters. Some key forensic features include simultaneous MD5 and CRC32 hashing generation during the data capture.
Hashing on the fly. That saves a step later.
Exactly. It verifies the copy's integrity as it's being made. It also has built-in write protection for the source drive, often a touchscreen interface for ease of use, and typically includes a wipeout function to sanitize drives quickly as well. For security, some models even include biometric features like fingerprint recognition to ensure only authorized users can operate the device.
Biometrics on an imager, that's serious.
It reflects the sensitivity of the data being handled. And for even larger scale operations, perhaps in a busy lab environment, you have machines like the ImageMaster 3002 SCSI from ICS. This is an industrial-grade high-speed disk imager. We're talking operating speeds potentially exceeding 3.9 gigabytes per minute, and it can copy to 4 target drives simultaneously with little to no speed degradation.
4 targets at once.
Yes. It supports multiple SCSI interfaces, which you might find in older servers or high-end workstations. Its wipeout function can sanitize up to 5 SCSI drives simultaneously, also according to DIG specs. These image master machines, whether for ID, SATA, or SCSI, are clearly industrial strength units designed for high-volume, high-integrity imaging. They're definitely not your everyday USB duplicator you buy online.
So these are the workhorses in a forensic lab, really designed for throughput and uncompromised evidence handling.
Exactly. They are often the core imaging stations in forensic labs, engineered for sheer speed, reliability, and maintaining that uncompromised chain of custody for the digital evidence. They ensure every bit is captured perfectly and verifiably.
Makes sense. Okay, just like with the software, the full list of hardware devices mentioned in the guide, Table 13.2, is extensive. Looking at this array of physical tools, what's the main takeaway? How do we summarize their role in the forensic process?
The key takeaway is that hardware devices provide a level of physical control, speed, and often simplicity for specific tasks that software alone can struggle to match, especially when it comes to the crucial first steps of evidence acquisition and preservation. They deliver undeniable guarantees against data alteration at the physical interface.
So physical control, speed, reliability.
Precisely. We can group them by their primary functions, similar to how we categorize software. First, you have the write blockers. These are absolutely paramount for evidence integrity. They include devices that physically block write commands to hard drives via various interfaces, IDE, SATA, USB, FireWire, and also specialized readers that protect volatile flash media like SD cards. Their sole purpose is to ensure the original evidence remains pristine and unaltered during examination or acquisition. Second, the data acquisition and duplication units. These are the high-speed workhorses for creating those forensically sound copies. They range from portable, single-drive imagers suitable for field work, like the Solo IT, to industrial-grade machines capable of simultaneously copying multiple hard drives at high speed, like the larger image master units. They often have built-in features like on-the-fly hashing, support for HPA-DISA areas, and multiple imaging formats. They're about making perfect, verified copies quickly and efficiently. And third, the drive wipers. These are hardware devices dedicated solely to securely erasing data from drives, often adhering to stringent government standards like DoD 5220.22 MIN. They ensure that data is irretrievably erased, which is vital for sanitizing media before reuse or disposal in sensitive environments.
So blockers for protection, imagers for copying, wipers for sanitizing.
In essence, yes. These specialized hardware tools are truly the frontline defense against evidence tampering and form the backbone of efficient, forensically sound data acquisition and handling. They work hand in hand with the software tools by providing that essential physical layer of control and speed where it matters most.
Okay, we've taken a truly deep dive into the world of forensic software and hardware. Wow! That was a lot of ground covered, covering everything from tiny utilities to massive hardware arrays, but you've made it incredibly clear. Let's try and quickly recap some of the most critical takeaways for our listener.
Absolutely. It was a lot, but let's boil it down. First, let's reinforce the indispensable nature of specialized tools. We've clearly seen that standard, everyday software and hardware are simply insufficient for digital forensics. This is due to fundamental concerns about maintaining data integrity, achieving the necessary depth of analysis to find hidden or deleted evidence, and meeting the stringent legal requirements for admissibility in court. Forensic tools are specifically engineered to overcome these critical challenges.
Right. Standard tools just aren't built for forensic rigor.
Exactly. Secondly, we explored software's versatility. These digital tools cover an incredibly vast array of tasks, everything from monitoring user activity with solutions like Visual Time Analyzer to comprehensive case management and deep drive analysis with powerful platforms like Xways Forensics and Incase. Software extends to specialized data recovery, on-track, device seizure for mobiles, secure deletion with tools like DBAN, ensuring file integrity with hashing utilities, and performing advanced analysis using tools like net analysis for internet activity or REC for reverse engineering compiled code. Software gives you incredible analytical power.
So much flexibility on the software side.
Definitely. Thirdly, we highlighted hardware's core advantages. Physical hardware tools bring unique benefits to the table, primarily offering superior speed for acquisition, greater portability for fieldwork, and, most importantly, undeniable hardware-enforced write protection. Devices like no-write, lockdown, and the ICS drive locks are crucial for preserving original evidence integrity. And dedicated imagers, such as the Image Master series, provide high-speed, forensically sound duplication, often with built-in validation like real-time MD5 and CRC32 hashing. Hardware provides that physical guarantee.
Speed, portability, and that rock-solid write protection.
Key advantages. It's also vital to understand the why behind each tool. Every tool we discussed, whether software or hardware, serves a specific, deliberate purpose within the overall forensic workflow. They are designed to overcome particular technical challenges, access data others can't, or meet specific legal and procedural requirements. It's about picking the right tool for the job. We also emphasize the importance of validation. Remember organizations like NIST CFTT. Their role in independently testing both software and hardware tools is critical. Practitioners must be aware of how these tools are evaluated and choose validated tools whenever possible to ensure their reliability and bolster their credibility during investigations and potential court appearances.
Validation matters for trust and admissibility.
Absolutely. And finally, the sheer number and variety of tools we've touched upon underscores that digital forensics is a dynamic and evolving landscape. Technology changes constantly, new devices emerge, new techniques are developed. This field requires continuous learning and adaptation from its practitioners to stay effective.
That's a great summary. And remember, as we discussed, you, the investigator, don't need to own or master all the tools, but understanding their functions, their categories, and their applications across different operating systems is what truly makes you an effective CHFI.
Yes, that's precisely it. It's about having that foundational understanding of the types of evidence you might uncover, deleted files, hidden data, system artifacts, and the fundamental principles behind recovering and protecting it forensically. The tools, ultimately, are merely powerful extensions of that knowledge and methodology.
Okay, let's tackle a few lingering questions someone might have.
Yeah.
What types of evidence can forensic tools really recover that someone might not expect, beyond just the obvious files?
Oh, forensic tools can recover a surprisingly wide range of digital evidence, often things users have no idea are even being recorded. Computers store vast amounts of information, much of it without conscious user awareness or interaction. So yes, this includes tangible user files, of course, but it also includes critical system files that reveal the system's state and configuration. It includes files that users have intentionally deleted. It includes fragments of data residing in areas like slack space and unallocated space, those digital crumbs left behind after files are deleted or moved. They can even uncover data from hidden partitions that aren't normally visible and gather system data logs, registry entries, temporary files that is critical to understanding the computer's tasks and the user's actions, sometimes even reconstructing timelines without the user's direct input. It's a very deep well of potential information.
Wow, so much more than just the files you see in Explorer. Okay, another scenario. If I'm unsure what occurred in a situation, maybe a minor incident, and I think the case may never go to court, do I still need to go through the effort of imaging the drives? It sounds like a lot of work if it might not even be used.
That's a common question, but the best practice answer is almost always yes. You never truly know what may occur in the future, even if a case seems minor or unlikely to escalate right now. Imaging the drive is always useful as a standard practice for several compelling reasons. Firstly, if something does turn out to be more serious later or new information comes to light, you have that pristine, unaltered image captured at the earliest opportunity to refer back to. You can't go back in time to capture it later. Secondly, from a professional standpoint, being able to demonstrate that you consistently use imaging tools as a standard operating procedure makes your entire forensic methodology much more difficult to attack in court, even on completely unrelated cases in the future. It establishes a pattern of diligence.
So it builds credibility for future cases too.
Exactly. It establishes a provable chain of custody and demonstrates an unassailable methodology that strengthens all your findings. So the recommendation is firm. Always image the drive if forensic analysis is even a remote possibility.
Okay, always image. Last question then. If I have that read-only image created using a write blocker, maybe stored on my forensic workstation, an image that I know I can't accidentally write back to do them, I still need to scan that image file for malware. It seems safe since it's just a copy and it's read-only.
Absolutely. Unequivocally, yes. You must still consider the potential for malware within the image. Any forensic image file, especially a full bitstream copy that contains 100% of the information from the original hard drive, has the potential to introduce a virus pathway into your secure forensic workstation or network if handled improperly. Malware could be dormant within the files inside the image. If you were to, say, mount that image as a writable volume accidentally, or extract and execute a file from it without precautions, you could infect your analysis system.
So the image itself carries the risk from the original drive.
Precisely. Therefore, any forensic investigation must exercise appropriate care in ensuring that none of these pathways exist. This usually involves scanning the mounted image, using up-to-date antivirus tools within a controlled environment before beginning deep analysis, or using analysis tools that don't require executing files from the image directly. Treat every image as potentially hostile until proven otherwise.
Got it. Scan the image too. Okay, that clears up a lot. What a journey through the essential software and hardware that empowers digital forensic investigators. It's truly a testament to human ingenuity, isn't it? Both in committing digital crimes and in developing the tools to solve them. It feels like a constant arms race in the digital realm.
Indeed it is. And as you, our listener, continue your path to becoming a certified computer hacking forensic investigator, remember that the true power lies not just in the tools themselves, impressive as they are. It lies in your ability to critically assess situations, to apply the right techniques and tools methodically, and crucially, to interpret the digital breadcrumbs these tools help you uncover. The tools find the data, you provide the analysis and context.
So, as you step away from this deep dive today, consider this provocative thought we'd like to leave you with.
In a world where digital evidence is constantly changing, where volatile memory holds secrets, and where even a deleted file often isn't truly gone, how might our very understanding of time and identity evolve within the legal system, especially in the courtroom, when potentially every digital action leaves a timestamp and a trail, even if it's hidden deep within unallocated space or system logs?
Think about that as you prepare for your next step in digital forensics.